Today I'm going to talk about how to convert a decimal number to a binary number. So first of all, let's discuss about decimal number. So we can say it is a term which basically describes base 10 number system. So now what is this base 10 number system? This base 10 number system is nothing but those numbers we are using in our day-to-day life, and those numbers are obviously 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the 10 numbers, and this is the reason the base is also 10. Okay, so now suppose I'm writing 75. Okay, so how can I represent this in terms of base 10? Actually, we all know since our childhood how to represent this 75 in terms of 10, but still I am writing it for better understanding. So how we can represent this in terms of 10? Obviously, this means 7 tens plus 5 ones. Okay, so that means 5 into 10 to the power 0 plus 7 into 10 to the power 1. So here now you have got a clear idea that whenever we talk about decimal number system, it works with powers of 10. It deals with the powers of 10 only. Okay, similarly, suppose I am writing 100. So it is how we can represent this 100 in terms of 10. It is very easy, like 0 into 10 to the power 0 plus 0 into 10 to the power 1 plus 1 into 10 to the power 2. Okay, so actually 10 to the power 0, that means anything to the power 0 is equal to 1 only. So here we have 1 into 10 square plus 0 into 10 plus 0 into 1, so which is equivalent to 100 only. Okay, so this is the way how we represent decimal number. So now let's talk about binary number. Okay, binary number, similarly, it is a term which represent, or we can say which describes the base 2 number system. Okay, so now what is this base 2 number system? The number system which deals with only two numbers, and those numbers are 0 and 1. So basically I mean to say, if I am writing 75 in terms of base 10, then what will be the value of this 75 in terms of base 2? Now we'll see that. So here I'm gonna show you two methods. First method is subtraction method, and second one is successive division method. Okay, so first method, you can say you will learn how to convert, and second method we can say it's just a proof of the first method. So let's start with the subtraction method. So we have 75, and obviously when we were talking about base 10 numbers, it was dealing with power of 10. So similarly, when we are dealing with binary number system, it will deal with obviously powers of 2 only. Okay, so here comes the main important thing, like if you can remember this powers of 2, then it will be very good, because here only important thing is this powers of 2 only. Okay, so we have to take the powers of 2. So let's take like 2 to the power 0, 2 to the power 1, 2 to the power square, 2 to the power cube, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7. Okay, so anything to the power 0 is equivalent to 1. This is 2, this is 4, this is 8, this is 16, this is 32, this is 64, and this is 128. So now look at your number. You have to convert this 75. Okay, so now look at this powers. You have 64 and 128. So basically 120 is greater than 75 and 64 is lesser than 75. So basically this will be enough for converting this 75 to a decimal number. We don't need this 128 because it is higher and there is no meaning of taking it. So now I'll remove this 128 because we don't need it. So we have 75. So what is the highest number we have? We have 64. Okay, we have the highest number 64. So simply just subtract this 64 from 75. So you will have 11. Okay, now again look at this powers of 2. So you have 11. So now see, this 16 is again greater than 11 and 8 is again lesser than 11. So obviously we'll take 8. So now let's take 8 and let's just subtract this 8 from 11. Now you will have 3. Again 4 is greater than 3 and 2 is lesser than 3. Obviously we'll take 2. Just subtract this 2. Now we'll have 1 and we'll stop here. So 75 is equal to 64 plus 8 plus 2 plus 1. Okay, so we have 64, 8, 2 and 1. So now you have to just write 1 under these numbers. Okay, so after writing this 1 we have some blank space like 32, 16 and 4. So just write 0 under these numbers because we don't need this 32, 16 and 4. To represent this 75 we only just need 64 plus 8 plus 2 plus 1. Okay, so this is the reason you can write 0, 0, 0 because we are adding these numbers, right? We are subtracting and we are adding. So if we are writing 0 over there, then you can say that if 64 plus 32 you have taken 0, so you can write 0. So again 0 plus 8 plus 0 plus 2 plus 1, so which is similar to this only. So you have to write 0 over there and you have to write the number you are taking or the number you are getting after subtracting. Okay, okay, so you have 75 in terms of 10. Okay, so the binary conversion of 75 is 100 1011. Okay, so this is the binary conversion of 75. Okay, so now this 10 and this 2, I guess you have understood that this 10 is the base and this 2 is also base. Okay, so now let's talk about successive division method, which is actually the proof of this one, proof of this subtraction method. Okay, so successive division, you can see here it is mentioned division. So obviously we have to deal with powers of 2 and here it is written division. So we have to divide this number in with we have to divide this 75 by this 2. Okay, so let's just divide it if you are dividing, then you have 37 and you have the remainder 1, because 37 into 2 is equal to 74 and this is the remainder. Okay, now again divide this 37. 18 into 2 is equal to 36. Again you have remainder 1. Again divide this 18 by 2, so it will be 9. Now you don't have any remainder, so you have to write 0. Again divide it 1. Again divide it. Again no remainder, write 0 and 0. Okay, so we'll stop here because we have got 1. So now always while applying this method, you have to take the numbers along with this path, like you have to take from last to first. Okay, so just write it 1 0 0 1 0 1 1. Okay, so here also we have got the same answer, 1 0 0 1 0 1 1, and similarly we have got the same result in the subtraction method also. So this is the way you can convert any decimal number to a binary number.